Welcome! In today's video, we're going to take our player and we're going to add a new Footstep audio player scene. That, as you can hear, is going to dynamically update the footstep sounds of our player depending on the tile map layer that we're walking on. So if you want to learn how to do that for your own game, then stay tuned. Hi, my name is Michael. Welcome to my 2D action and adventure RPG tutorial series. Follow along and learn how to create your own AARPG in Godot 4 using GD script. Alright everybody, so in this tutorial we're going to take a look at how we can create some dynamic footsteps on the player. And I'm not going to do this in the most simple fashion because I want it to be modular and reusable. And I also want to kind of dive into a few topics and other things that kind of make this feature a little bit more dynamic. So the first thing that we're going to do is we're going to build a new scene that we can use. This modular scene will be our Footstep audio player scene. And it's going to be just essentially a custom audio player that has some footstep sounds associated with it. And then the next step is going to be to add that to our player and hook it up so that the animations can tell the footstep thing that, hey, we need to play a footstep sound here or there, right? So that we'll just kind of sync that with the animations. And if you wanted to put this on something other than your player, it would be as simple as adding this scene to that other entity, maybe an enemy, and adding it to the animations or to the script, okay? And then once we have that in place, we're going to work on our tile set that we have, and we're going to add a custom data layer that's going to contain the footstep type that we can kind of paint onto the tile set. And then as the player is moving around the scene, in the next step, we will kind of connect the dots by checking which part of the tile set we're over whenever we need to play a sound and making sure that we play the correct footstep sound. And then the last thing that we'll do is we're going to take this footstep audio scene that we've made and we're going to implement an AudioStreamRandomizer as the stream. In the past, I've used just a simple script to randomize the audio by giving it a slightly random pitch and maybe adjusting the volume. But we can actually do this with the AudioStreamRandomizer. There's a few other uses for it as well, but we're going to implement that in this video. It's going to help the footsteps sound a little bit more organic, less robotic, which they sound pretty robotic right now. It should be said that I'm building this on the project. This is part of my Action RPG tutorial series. However, if you're not following along with the series, you should be able to follow along with this tutorial and implement all of this in your own project. Just make sure that you've got things in place to hook it up to. You know, you probably need something like a player, and hopefully you've got some tile maps. And either way, whether you're following along or not, you can go to my itch.io page and download the miscellaneous.zip file. Within that zip file, you will find the 3 footstep audio wave files that we're going to use for this tutorial. So let's get started. All right, so let's get going on this. Now, looking at the scene here, I'm not actually going to be adding anything to this scene, but I just want anybody that hasn't been following along with the tutorial to see kind of what we've got. An example level where I've got this world and it's, you know, drawn with this tile map. And we'll use that later in the tutorial to add our, you know, footstep types too. But for now, I want to start here in my file system, and I want to create the folders and the resources I need. And if you look under my general nodes folder, I've actually already created a folder called Footstep Audio 2D. That's the new scene that we're going to make. And I've already dropped in the audio files, which you can find linked in the description on the itch.io page. Again, that's in the miscellaneous zip file. And so in here, let's go ahead and create a new scene. And we'll call this, we'll just call it the same thing as the folder, maybe footstep _audio _2D. And we could choose what we want it to extend, but for now, I'm just going to leave it on 2D scene. And yeah, we'll say, okay. So we've got this new scene here. And then while we're here, I'm going to rename, I want that D to be capital. I'm going to go ahead and attach a script to this scene. And that should create a script of the same name. I don't want a built-in script. I must have been playing around with something. That'll create a script of the same name in that folder. So I'll go ahead and create that. And there we go. So we've got our scene and we've got a script. We do want to go though to this scene, and you know, I probably should have updated it first. We don't want it to be a node 2D. We want it to extend an audio stream player 2D. Okay, because that's the root node that we want this to be. So let's go ahead and in our scene, I'm just going to right click and say change type and search for audio stream player 2D. There we go. Okay, so we've got our audio stream player and we've got a script attached to it. Now, before we configure this, let's go ahead and just set up some of the basic GD script stuff that we need. I'm going to go ahead and give it a class name. I just like to get in the habit of doing that. We'll just do that. Footstep audio 2D. To begin with, this footstep audio, where we're going to start at least, it's only going to need one export variable. And what this is going to be is it's going to be a collection of footstep sound effects. So we've got the 3 footstep sound effects here. So we'll just call this footstep variants maybe. And this is going to be an array of audio streams. Okay, just like that. Now you could just hard code these resources in here. You could kind of come in here and preload them or something like that. The reason I don't want to do that is because I'm trying to keep this a little bit flexible so that if you were to say drop this onto an enemy and you wanted to override the footstep sounds, you could provide your own. Okay, so let's go ahead and just get into this. Now, the only other thing that we're going to do right now is we're going to make a new function that we'll call play footstep, because this is the function we will call in our animation player when we want the footstep sound to play, right? And because we haven't assigned an audio stream, we could grab that here, but maybe what we should do to begin with is I'm going to grab footstep 3 because this is the grass sounding footstep effect. We can play that back real quick. Yeah, so there we go. That we've got that in there. We'll just assign this for now, and so all we're going to do in the play footstep is call play. Now, the reason we could just call play, obviously, on the audio stream player or on this class, we don't need a function called play footstep to play it. But the reason we're going to add this in a separate function is because in a little bit here down the road, we're going to dynamically change the footstep sound based on the tile map, right? So we'll go ahead and change that later, but that's why we're going to put it in a separate function, okay? But for now, we'll just have it play, and I'm going to go ahead and save that. And I'm going to go to my player scene. So if you're following along with my tutorial series, you have a player just like this. And all we really need to do to get this to work is I'm going to drop in my footstep audio player scene. And you can see the footstep variant array is empty, but we have assigned this stream here. But just to get this hooked up, I want to kind of get into step 2 of this, which is just hooking this to our animation player. So I'm going to come in here. Now, my player has some various walk animations like walk up or walk down, up, and side. So if I come in here, your project may be set up differently, but just figure out where you want these to play. And this is using a ping-ponging loop in my animation, you'll notice. So what I'm going to do is just come to the middle so that it starts playing the sound right about here, and it should line up kind of with his foot. The thing about footstep sounds that's kind of hard to get right sometimes is, the audio starts, but it might not. If you play the footstep audio right when the foot touches the ground, it's actually going to sound like it plays a little bit after sometimes. So I'm just going to come in here right in the middle. I'm going to add a track, and I'm going to use this call method track and select my, footstep audio 2D. And then I can come in here and insert a key. And you can see the script has the play footstep method, and I'll just go ahead and add that. Okay. And now what'll happen is every time this animation is playing, right? Every time it hits that frame right there, it's going to call the play footstep sound on our footstep audio 2D. I'm going to go ahead and apply this same footstep audio track to my other animations, and you should do the same, and then we'll be ready for the next step. And I've actually got several other animations that include walking, so I'm going to add it to those, but I'm just going to skip that part. Okay, so you can see here that I've added my play footstep to my last walking animation. This is the one when he's charging his weapon. I've got a special walk animation for that. But it's all set up for my game, so we should be ready to kind of start testing this out. Let's just make sure everything's hooked up good, and maybe we'll run this and see. We've got our footstep audio 2D scene as a child of my player. My player already instantiates in my game, so I should be good there. And his animations call this play footstep. And then looking at our footstep here, we do have a stream assigned. So if all works well, this should function. So I'm going to go to this scene, this level 2 that I've got, and just run the scene. Okay, first step done. Now that audio is kind of loud and obnoxious. I'm going to leave it that way so that it's easy to hear in the recording, because it's actually quieter to you guys than it is to me. But we'll come back and adjust that in our final step when we're randomizing and fine-tuning the audio. But there we go. We've got this stream player that plays a footstep audio, right? So first two steps of the system are kind of complete, right? We've got our footstep audio player scene. It does support 3 footstep sound types. We haven't done that yet, so we'll go in there and maybe add those, and then it'll play a footstep audio. So let's just wrap up that first step and let's just look at this footstep audio. By default, I want to increase the size of this footstep variant array to 3. And then for each of these, I can, load them, or I can drag and drop in. So I'm going to say, I'm actually going to put footstep 1 at the end in the slot, index 2. Sorry guys, I know that's backwards, but footstep 3, as you heard, was, it's a bit crushed, but that's my grass sound effect. And then 2 is kind of like more like dirt, and 1 is more like a hard floor, okay? So I'm going to use that as the third one, because for me, the grass is going to be the most common type of ground in my game. That's why I want it on 0. And you'll see that as we get into painting the tile sets and we add a new custom data layer, the default value of that data layer is going to be 0. So that way, if I just have a new grass map and most of it's grass, I don't have to paint 0 in the whole thing. I only have to paint in any tiles that would have a different footstep type. All right. Okay, so there we go. Bada bing, bada boom. Now we're not using this array quite yet, but it's set up and it's ready to use. Before we can use that array of different footstep sounds, we need a way to kind of tell the footstep audio 2D scene what type of sound to even play. Otherwise, it's not going to do us any good, right? So we're looking now at this third step, the TileSet custom data layer. We're going to add a custom data layer to our TileSet to identify the footstep type per tile. So if we're looking at my project, I've got my grass tile, and this is actually a scene, and we're going to be adding the data on this TileSet. So, if you just had a TileMapLayer or just a regular tilemap node in your scene, you could edit the TileSet, or if you have a TileSet resource, that's where you're going to want to edit it. I'm going to open my grass tiles 01 scene because this TileSet is just saved as part of the scene data. Okay, so if I expand the TileSet, you'll see, and I'm going to go ahead and open this down here because we're going to be working in our TileSet editor. When I expand this, you can see I've got different settings, right? And we've set up in my project a physics layer on these. And, if I go in here to paint and look at my physics layer, you can see I've painted in where the walls are. And then there's terrain sets, and we've got one of those defined here. And then there's navigation layers and custom data layers, as well as a special rendering layer. And this custom data layers is where we want to work. So we're going to add an element here, and I'm going to call this footstep type, footstep_type. Okay. Kind of small in there, but there you go, footstep type. And the type of data that I want this to be, any means you could put anything in there. I specifically want to use an integer so that this is going to relate to my array of footstep types. So we're going to have 0, 1, or 2 are the valid values that we could use. So there we go. We've got this custom data layer, and I'm going to save that. Now when I'm looking at my paint settings for the tile set. This is painting settings across all of them. You could select a tile, and we could come in here, and if I select a tile and look at the custom data, the footstep type is 0. But when I go to paint, if I go down to this paint properties and I select my footstep type, what's nice about this is you can see all of the types laid out. And right now, all of the footstep types are set to 0. Now, footstep type 1 is going to be for my dirt paths. So I'm going to select 1, and I'm going to come in here, and you could just paint them one by one. You can also hold Control Shift and then click and drag to get a box. And if you can see those tiles are highlighting with a blue highlight border to indicate that they're going to change. So when I let go, those are all of type 1, except I don't want this little guy to be 1. I want that to be a 0. Okay, so now I've got 2 different types in here. And just for fun, I'm going to go to footstep type 2, which is going to be our hard, and I'm going to just paint it on this little rock. Okay, so we're going to have one of these other footstep types. So of the 3 variants I've got, this one tile set will have tiles that will be associated with each footstep type. And now when I save this, if I look at my scene here, you can see I've got some rocks painted, and obviously I've got paths, and I've got a lot of grass. So once we get this hooked up, we should be able to hear all 3 different footstep types on this one tile set. All right, so now we're on to this fourth step of connecting the dots, right? And what we've built so far is probably a little bit confusing how we're going to connect it. There's a few ways we could connect these two things, but in order to make it simple, I've determined that we're going to use something that I haven't covered in any of my tutorials before, which is the node group system within Godot. And we're just going to look at generally how can we connect that to this. You know, if we look at our player, we've got this footstep audio thing. There's no obvious connection. And we could do something like create an auto load script, you know, have a singleton that kind of handles that in a message bus system or something along those lines. But what I feel is kind of fun and unique and maybe a little bit simpler in this case is to handle it through the node groups. So let's first look at what these node groups are. And I'm going to go to my grass tile set. So what you're going to do is just find your tile set. If you're following the tutorial I've got, then you know you've got your grass tile. And when we select a node in the scene, if you look over in the inspector, next to it you should see a tab that is called node. And underneath node you'll see signals and groups. And we're going to be using these groups. And there are two types of groups. There's scene groups and there's global groups. And we want global groups because they're globally accessible, whereas scenes are only accessible within the scene. At least I believe that's the simplest way to explain it. And if that's not correct, you know, comment below. But what we're going to do is I'm going to go ahead and create a new global group. So we can just click add here and select global, and we'll give this a name. And I'm going to call this, I'm just going to call it tilemaps. And then we can give this group a description, you know, just make it easier to understand. And it doesn't need to be anything fancy. So I'll just say something. Okay. And now this grass tile is assigned to that global group, and you can check and uncheck it. And in fact, if I were to look at this scene, I've got this other shop tile map, and this is a scene of its own. And I could come in here and check tile maps if I wanted to, or I could uncheck it. I'm going to go ahead and check it because at some point I'm going to want to add some footstep effects to this tile map as well, right? So I'll go ahead and save that change. Another way you could access these global groups is if you go to project settings, and then underneath the globals, you can see there's a couple tabs now. If you're in an older version of Godot, this might look slightly different. It might be its own tab up here, but underneath globals, we've got groups, and there's that group we created. You could go ahead and create groups here, and you know, you could create a new group, and I'm not going to give it a description. And then that new group, if I were to look at my tile map, it's now displaying in my global groups. So these groups are nice. It's an easy way to group objects by type, right? Or by functionality, maybe. Use them however you see fit. I'm going to go ahead and real quick just remove that new group thing because I don't want that. But not only are these nice for grouping items in a way that's easily accessible through code, but it's going to make it really easy for us to grab these tile maps from our audio script without having to have any other special script or class to do so. Okay, so now that we've got that set up, if we come over to our footstep audio scene and let's look at the script here, what we're going to do is we're going to address this piece of the code where we made the comment where we want to dynamically change the footstep stream source. Let's go ahead and create a function to do that, okay? And we'll just call the function something like getFootstepType. Okay, and then now that we've got this, let's just go ahead and plop this in right here in place of that comment. Okay, and we're just going to separate this out so that the play footstep doesn't get too cumbersome. But what do we need to do in here? The first thing we want to do is we want to get all of the tile maps that we've assigned to this new node group that we created. And you don't have to assign all of your tile maps to this group. You could rename that group or use it exclusively like we're going to do for the tile maps that have footstep sounds associated with their tile data. And so again, you may want to make a special category for that. I'll leave that up to you. But in order to do this, we're going to grab all of those and then we're going to iterate through that group. So each time we go to play the footstep, we're going to do the following. We're going to first say for t in, okay, t is going to represent the tile map variants that we're going to iterate over. And we'll just say get tree. And then within the scene tree, there's a function that we can use here, and it's called get nodes in group. So get underscore nodes in group right there. And then we can pass in a name as a string. And what was the group name? We just call it tilemaps, right? And you can see it's actually showing up automatically because this function is smart. It knows what our global groups are. So there we go. So we're going to get each of those, and I'm just going to go ahead and put a pass on here so that this warning will go away. So we're going to get a group of all of our tile maps that are currently in the scene tree and iterate over each of them. And we need to first do a check just to make sure. I like to do this kind of check so that we avoid errors, but we only want to continue if our T is actually a tile map, because it might be possible that we assign something to the tile maps group that is not a tile map, or maybe we have multiple types of things we assign to the tile map group. I don't know, but we want to just make sure that this is a tile map layer, okay? Because that's what we're expecting. You know, you might be using tile maps. If you're like me and you've updated with the new tile map layer, then that's the type of node. Oop, I want it to say if T is tile map layer, just like that. Okay. So if it's tile map layer, then we want to continue to do something with it. And what we need to do is we need to find the tile cell that this footstep node is over top of, right? And I'll just show you something real quick. We didn't talk about this earlier, but this footstep audio 2D, if you look, see, it's right here at the bottom of his feet. That's the 0 position of my player. So wherever the player is walking, this node should be on top of it. So underneath that, we need to figure out, okay, for each tile map, what's the tile that I'm on top of? And then we can check it for the tile map data, right? So in order to do this, we could say, I'm going to make a cell variable. And, you know, cells in a tile map are stored as kind of like an array of vector2 integers. So we'll just say that this is a vector2i. This is a special type of vector2 where the values are whole numbers, right? So this cell is going to be represented by this vector2i. And in order to find that, we have a tile map layer T. And our tile map layers have a function built in that we can use to fetch it, and it's called local to map. There's also map to local, but what local to map does, we'll look at the documentation here. Local to map returns the map coordinates of the cell containing the given local position. If local position is in global coordinates, consider using node 2d.toLocal before passing it into this method. And what this is talking about is, if you're familiar with Godot, we've got two different coordinate spaces. We've got local and global. And this is actually kind of important here, because if we look, like, let's look at our player scene again. And if we look at this footstep audio, and if I pull up the inspector, the transform position of this is 0, 0. If we get the position of this footstep audio, it's always going to be 0, 0 because it's never moving, right? If I move it over here, it's 35, -4 or whatever. Okay, but we're not moving this. We're moving the player node. So what we need to do is, if we call to get the global position of this footstep audio, it won't be 0, 0 anymore, because now it will also consider the position of its parent node and so on. And then it'll look for the position globally. Okay, so that is actually kind of important, because if we go back to our script and look at this documentation, we're going to pass in a global coordinate, and then it says you might want to convert it to local. Now that's important, because if we go back and look at our tile map, so actually let me look at my level. If I've got this level here, and let's say my tile map has been drug over here and its position is not at 0, 0, okay, then what we need to do is take that global position and convert it to a position that fits within this grid, which will take into consideration the position of the tile grid itself, or the tile map layer. Man, did that make any sense? I hope it helped a little bit with this. So what we're going to do is we're going to grab the global position of our footstep audio and use it to find the cell using some of these methods here. Okay, so let's just write the code, and hopefully this will help it make more sense. Okay, so we've got this local to map, but obviously, as we've been discussing at length, we're not going to pass in a local, the regular position, right? We could just pass in like position or something like that, right? But what we want to do, we want to pass in the global position. Okay, global position is the global position of this footstep audio 2D node. Okay, but we need to take this one step further, because remember, if our tile map is off center, we still need a function that's going to convert this to the local space of our tile map. That's what we want to do, right? Because if the tile map is off and we pick a global position over here, okay, so in order to do that, we can say t dot, and then the function is to_local, and then we pass in our vector2. Okay, and this is just kind of running off because it's kind of a lot of text. Okay, so if we look at this in reverse, it makes a little bit more sense. So we're going to take our global position of the sprite. We're going to find its position locally in relation to the tile map. And then we're going to find the cell at that location, the cell of this same tile map. Okay, so I hope that makes a little bit of sense. So this is going to give us something. And if we just were to print right here, we could print cell. And let's go ahead and just run the project and see what happens. Let's see, I'm on my scene 2. I'm going to go ahead and run this scene. So if this is working, we should see some, we got 6, 6. We should see some numbers changing. Okay, so you can see it's now printing out, each time a footstep sound plays, it's printing out the location, that cell that we're at, okay? So I think that's working pretty good so far. All right, so next, what we need to do now that we have the cell is we need to get the data of that cell. I'm going to remove this print and I'm going to say variable data. The tile data is a class just like that. So data of type tile data equals, and we're going to go again to our T, which is a TileMapLayer, and the TileMapLayer has a function to help us do this as well, and it's get cell data, or get cell, not cell data, but cell tile data. Yeah, just like that. And you can see it's expecting coordinates in the format of a vector2i, which is what we just calculated for our cell. So we just pass that in, okay? And then let's go ahead and for fun, let's print the data out now and let's see what this looks like. So again, if this is working, let me just shrink this window so we can see. Yeah, you can see we've got some tile data here, and this is a reference to that tile data in memory or something. Then we've got a null. So maybe we stepped on a tile that doesn't have any data, but it looks like we're finding some stuff, right? Okay, so that's pretty good. Because we had a null in there, we're going to have some errors sometimes. So let's do a check. We'll just say if data, right? Meaning as long as it's not a null value, then we'll continue to work with it. Now that we've got the data, we want to grab that footstep type. If you recall, since I've got my grass tile selected, you can see my custom data layers. It's this footstep type. Okay, so let's just check for that. We can say var type equals, and then we'll say data.get underscore custom data, and then we'll just say footstep type underscore type. I think that's how we spelled it. In fact, let me just copy that and paste it. It should look the same. Yeah, there we go. Okay, so our type is going to be getting the data with that name. And then we can go ahead and just set our stream now. So now we know the type. It's going to be either 0, 1, or 2, right? If we look back at how we set up this tile set, if we're looking at how we painted these things, let's go over to paint here. Sorry, I had Godot crashed on me, but just looking, if I look at the footstep type, we've got these painted, right? So what we should be doing is we should be getting the custom data footstep type. We should be getting this value into this type. Okay. So what we can do, because these values correspond with the audio files that we have in our footstep variance array, we can just come in here and we can set our stream, right? Because remember, this extends an AudioStreamPlayer 2D. So we've got a stream property. It's this same property you see here in the inspector. We'll just set that to, and then we want to say footstep variance, and then we'll just get the footstep variant at whatever number we get from the type. Okay. So what does this function do so far? It checks for all of these, and it's going to find a type, and it's going to set the stream, and then we'll play that stream, right? Once that is done finding the footstep type. So if we save this and run our scene 2, we should hear some different audio files. Ready for this? Oh, except we got a bug. And actually, I knew we were going to get this bug. I didn't think it would happen quite so soon. But I think it's because what's happening is, if we look at scene 02, I've got this countertop here. This is part of that other tile set. Okay. And I don't think I have it set up properly. So there we go. We've got an issue. But let's handle that issue because we're going to run into something like this all the time. So I'm actually kind of glad we hit it now. So we can just do another check real quick. So I guess what we've done is we've gotten our type, and then we are setting it to the stream. But we just need to do a check right before we do that. And we'll just say if well, what is the error we got? Let's look at the error we got. TileSet has no layer with name Footstep type. Okay, so this is actually not what we want to check. We do want to do this one in a second. So right here, I actually left a blank space on line 14. The TileSet that we looked at didn't have this layer. So we can actually check before we do all of this code. Let's just do a check on each tile map. And we'll just say, we'll check if the tile map has that layer. So if t.tileset, okay, t is the tile map layer, TileSet is the TileSet resource. And then we'll say get custom data layer by name. And what we do is we pass in the name here. I'll just copy and paste Footstep type. And what this is going to do, we'll look at this code real quick, or this function. It's going to return the index of the custom data layer identified by the given name. And what this actually doesn't say is if it doesn't find the name, it gives us -1. Okay, I don't know why it's not in the documentation. I thought it was because somehow I figured out how to do this. So I found it some way. So if that custom data layer is -1, meaning it doesn't exist, then we can just say continue. Okay, and that's just going to go, I guess, on to the next loop of this. All right. Now, if we save that and run again, hopefully this should not get that same error right away. Okay, it's working. We've got a grass sound. Let's see what happens when we go on the dirt. Nice. Different footstep sound, right? And the rocks have a different one yet again. So actually, I mean, you might think we're done. We basically are, but it's working, okay? I'm not seeing any more errors show up, but I feel like there are going to be situations where we might have an error. And that situation might be like if we don't have a type, okay, maybe we've set something wrong, but I'm just going to say if it's null, then we'll say continue, I guess, right here, okay? And there we go. Just another little check just in case we have an issue with that. So we've got this function to get our footstep types. It seems to be working. It's sending it back, and it works with all the different tile maps, right? Like if I go ahead and let me just run the game again. It's working. If I go to the next scene, it'll continue to work. We're now on grass, right? And I don't think I have anything but just one rock. But I mostly have grass. Okay. So, I mean, if you're happy and you're done, then you can go ahead and move on. Now, these sound effects I have for these footsteps is not the most attractive sound effect, right? So that's what the last step is for, is let's just make the sound a little bit nicer. Of course, you can replace this with better sound effects if you are good at doing that kind of thing, or you want to buy some or find some good free ones. But let's look at the next step now. Okay, so we've done all the way down through connect the dots. We used our groups. Hopefully you've learned something new with this. We're covering several new topics, and we're going to cover one more new topic, and that's an audio stream randomizer. As I mentioned in the introduction, and if you've followed the Action RPG series in the past, we've used just a brief bit of code to set a random pitch and random volume to some of our things, like our sword swoosh attack, you know, to give it a little bit more of an organic feel, so it's not the same exact version of the sound over and over and over. And let's go ahead and set this up a different way, though, because there is a resource type or a type of audio stream designed specifically to provide that functionality. And I just didn't know about this at the time I made previous videos. So it's a fun way to do it. So let's go to our Footstep Audio 2D. And I'm going to go ahead and clear my stream. And what we're going to do is we're going to add a different stream in here. And if you look, there's an audio stream, there's an audio stream microphone, audio stream randomizer, audio stream generator, and a couple other things, right? Polyphonic. There's some cool things in here. We want this audio stream randomizer. It's got the little die icon. And we're going to use this to help randomize how our audio sounds. So if we expand the randomizer, you can see that there's a couple different playback modes. Random means it won't repeat. You can just do random, which I guess the difference is it might repeat the same setting twice. And then sequential, I think if you can add multiple stream sources. So for example, we could add 3 different footsteps here, right? Like this, and then it would go through each of those or randomly select those. But we're not going to randomly change the stream. Okay, we will add one stream. We'll just leave it empty for now because we do need a stream to play. But we'll assign that in code. So hang on for just a second. But what we do want to randomize is simply the pitch and the volume. And so I'm just going to bump up the pitch. I'm going to go kind of too far so that you can better hear it. So I'm going to set the random pitch value to 2. And then for the random volume, let's go like 4 decibels. I think that should be plenty loud or quiet. Okay, so these are, if you look at the tooltips, these are setting kind of the possible range of variation for these. So the intensity of random pitch variation, 1 meaning no variation. And then same with volume, the intensity of random volume with a value of 0, meaning no variation. Okay. But before this is going to work, we do need to update our script. So let's come in here. In order to set this, we can't just set the stream, because if we set the stream, we are replacing our randomize right here. Okay. It's going to replace it with the stream. So all those settings are going to just vanish. So instead, we need to be able to grab that random, what is it called? The randomize audio stream randomizer. We need to grab that and then change this stream setting that we have here that's currently empty. Okay. So let's go ahead and make a variable. We'll call it stream randomizer. And this is of type audio stream randomizer. Okay. And then we are going to want to add a ready function so that we can set this in the beginning. So we'll say func_ready. And all we have to do is say stream randomizer equals stream. Okay, because we've already configured it. You could create a new stream randomizer from code here and then assign it to the stream, but the way we've got it set up, this will work just fine. Okay, so we've got a reference to it now. So let's go ahead and come down here to our get footstep type where we're setting our stream. Now, instead of setting the stream, we're going to say stream randomizer dot set stream. And you notice the little tooltip here, we set a stream, we want an index and a stream, because there could be multiple streams. We only have one, so that's index 0. And then the stream we want to set is this same bit of code right over here. So I just deleted a little bit of that. So we've got footstep variance at the type index and just close my parenthesis. Okay. So look at that line of code. That's what we need to be able to get or to set that stream. Okay. We're getting the value here and we're setting it this way. Now, if we save this, it should work and we should hear the randomization. So let's go ahead and run our project once more. Holy cow, it's all over the place, right? You can hear the volume change isn't as drastic as the pitch change, but it's working. Okay, I'm gonna go ahead and close that. Now, what we really want to do at this point is 2 things. Let's bring these random values back into a more gentle, natural sounding range. And then overall, I think the footstep loud sounds are too loud. So I'm going to decrease those. So we can do that in the following way. Just make sure you're looking at your footstep audio scene. Okay. And I'm going to come down here. So the random pitch, I'm going to change to a very small value, like 1.125. It rounded it to 0.13. And then for the volume also, I don't want the volume to randomize too much. 1.5 decibels, maybe somewhere around 2, because actually 4 was kind of okay. It got a little bit too quiet sometimes. And then in general, I want to decrease the volume of this. I'm going to decrease it by quite a bit. I'm going to set it to -16. You can play with this, but -16 is going to drop it significantly below the standard game volume of the other, like our sword attack and things like that. So if I save this and run the game once more, go to my special scene here. All right, I like how that's sounding. So there we go. We've gone ahead and we've created this new Footstep audio player 2D kind of scene and hooked it up to be dynamic with our tile maps. And it's working quite smoothly. I don't know, we went a little bit roundabout in some of the ways that we implemented it, but this way it's modular. You could drop this onto an enemy and all you would have to do is just, plug into his animation, the little calls to the play footstep audio, and then he'll magically work just like the player. All right. So thank you if you've made it this far in the tutorial. I hope you've learned something new and that you've enjoyed the content. I'm always trying to improve and do more. And as mentioned, this is part of a long-running series. This is actually episode 64, and those of you who have been following along already know that. But I am trying to do quite modular videos, and I'm even going to be doing more and more modular so that this can apply to just about any game. And so if you appreciate the content, please give me a thumbs up or comment below or both. And if you want to see more of what's coming from me, go ahead and subscribe to my channel. That way you'll be able to be kept up to date on all the latest videos that I produce, whether it's part of this tutorial series or any other general video I do as I cover Godot and how to build a video game. And lastly, I want to give a huge shout out to my Patreon supporters. I appreciate you guys, and as always, we'll see you next time.